Evening everyone. Just a quick little information video for Simon really at Old Oak Corner. He's got a query regarding DCC systems with Electrofrog points and Seep PM1 motors. I thought I'd just put this together, see if it can help you out really, Simon. Right, Peco Electrofrog point. Okay, when they come out of the packet, bear with me because I'm only using holding the camera as well. When they come out of the packet, there's a joint across here and there which you need to cut off if you're using DCC system. So just pull that off with a pair of pliers or cut it off. And what I did, I soldered it back across here, there and there, basically because I don't want to rely on this little blade point here to take power down to this section of the point. Alright, and so by soldering, you can see the joint there and there. It gives me a permanent feed of negative and positive. Okay, now when I look at my track, I use black and red for power, red for positive, black for negative, and I always look at black out. So black out, red in, black out, red in. So that's positive, negative, positive, negative. Okay, so coming onto this small diagram, we have negative, positive, black and red. Okay, now looking at one of your queries was fitting these insulated fish plates. Okay, you need to fit these on every point if you're using DCC and the Seep PM1 motors. Okay, and the reason being is this. Let's take this example here, right? With the point set over to the right, going straight on. Okay, you would have positive, 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 positive. Alright, this whole section here would become positive, and this V-shaped Electrofrog becomes positive. Okay, so positive, 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 continuation. That's negative all the way down anyway. Right, no problem there. When this is switched the other way, that becomes negative, 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 the whole lot, that whole section there, and this whole V becomes negative because this section is connected to this section underneath. I'll show you that in a minute. So don't forget, if this now has gone negative, you still have an existing piece of track here which is negative out, black out, red in. So that's still positive. That went negative because you switched, so you need to put an isolating fish plate there. The same here. You've got an existing piece of track here, black out, negative, red in, positive. When that switches over to the right, i.e. turning, negative, 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 all the way down. Okay, so you need to fit these isolating fish plates, otherwise you're going to get a short. Does that make sense? I hope so. When this switches over straight, that becomes positive, 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 the whole lot becomes positive. Alright, that positive is okay, but you still got it there anyway. This positive, 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 don't forget that piece of track. That's always negative, so you need a fish plate in there, isolated. Okay, this section here, as I say, is all connected together underneath. Underneath there, you'll note that that is connected to there, and there. This little piece of cable here is the only part that's connected to the PM1 motor. That does all the polarity switching of the point. Okay, and that goes to, I can turn this around, the terminal F there on the Seep point motor. So if this was on your layout underneath the board, that way, fitted from underneath, flicking it over to the right as it is there, that would be E, terminal E, and that would be negative on my layout, because you can see negative black out, pushed over up to the there, becomes negative. So on mine, E would be negative. Flick it over, excuse me, flick it over this way, okay, to positive. That would become D. So D is positive on my display, on my layout. If you mount it under the board this way around, be careful. It caught me out once because D, which it's still on, is now black, negative. So you have to be careful which way you mount this under the board, that you don't get confused. You know, for instance, if I was mounting it this way and I look underneath now and I see, right, okay, that's flicking over to that side, so that's D, so that's red, that's positive. If I had mounted it this way and soldered my piece of red cable onto it, I would naturally think, oh, I've soldered the red cable there, that red has got to go to positive. Wrong. That red, if I use red cable, the D, because it's flicking over that way and it's mounted the other way around, that would be negative. So that would have to go to black. I know it's a bit confusing, but I think you get my drift. Be careful which way you mount this around. Take no notice of the cables you connect to these colour coding wise. You just have to remember that flicking over to that side, E is going to be positive, and flicking up to the other side, D is going to be negative, regardless of which way you mount this around. Okay, so going back to the diagram here, as I said, when you first get this, I snipped them off, cut them off there, and resoldered them there, giving me a better connection along this section here to there. There's always got to be a gap there, because don't forget, this section here and all this frog are connected together, and they will change polarity, i.e. negative to positive and positive to negative, when this switches. So the only time this is going to get power through is from the F connection on the Seep point motor, whether it's flicked over to the positive or negative. Okay, the F output then connects to this, so it controls the polarity whichever way the track is facing. So you do need these insulated fish plates fitted on every point on DCC, and I hope that makes sense. I know it's confusing. Once you've done a couple, it becomes straightforward. and quite easy, believe it or not. Anyway, that's the way I do it. If you've got any queries, drop me a comment on YouTube and I'll reply. And best of luck. So just to clarify why you need these insulated fish plates here, if your point is switched to this side, i.e. straight on, you've got positive, 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 positive. The Seep point motor is switched the frog to positive, 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 and because all this is connected together, that becomes positive, 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 continues. That's a continuous negative anyway, so nothing changes. Don't forget, this is all connected together as I said, so still positive, 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 positive. And don't forget, you've got an existing piece of track which is always negative anyway. Black out, red in, negative, positive. So you need to put a insulating fish plate there, because you've got a, otherwise you'd have a positive meeting a negative and you'd have a dead short. Same if this is switched the other way, the point switches the other way. The polarity of the frog is then switched by the PM1 motor. So this becomes negative, 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 or this becomes negative, or this becomes negative. So negative through there, negative, 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 negative. And don't forget, you've got an existing piece of track which is still positive, so you need an insulating fish plate in there because that's become negative because you switched the point. Hope that makes sense. So you need to fit these insulating fish plates, otherwise you're going to get a short every time that switches. Okay, thanks for watching.